Okay, Summer Physics 1-2. We're following up on our lessons on velocity with a lesson on acceleration. So what is acceleration? Acceleration is any change in velocity per unit time. So the faster velocity changes, the greater the acceleration. So the velocity can be changed by doing one of two things. We talked about this before, either making the object speed up or slow down, changing its speed. So we're considering that to be one thing, either speed up or slow down, change speed. The second, which is a little less obvious, is changing the direction of the object. So even if the object continues at the same speed but turns a corner, it is accelerating. So the units of measurement for acceleration are any unit of distance divided by any unit of time, and then divided again by any unit of time. The most common unit of measurement for acceleration we will use in class is meters per second, so that's velocity, per second. Meters per second, and that's abbreviated as meters per second, which is the velocity, per second. So it's how much the velocity is changing, meters per second, for every second that goes by. And that's often written as meters per second squared, and I can show you in class how those two are equivalent to each other. Okay, so what does an acceleration of 5 meters per second mean? It means that for every second that goes by, the car's velocity has increased by 5 meters per second. Now, it could have also decreased by 5 meters per second, or it could have to do with a change in direction. But the most obvious example of acceleration that you're familiar with is a car speeding up. Usually when you say someone or a car accelerates, it's speeding up. It's getting faster. So we're going to take that as our example. So what it means is that for every second that goes by, the car's velocity has increased by 5 meters per second. So let's say at time 0, that's your initial velocity down there, the car's initial velocity is 0 meters per second. So that's VO or V0. Okay, the car begins at an initial velocity of V0 equals 0 meters per second. Now, after 1 second, the velocity has increased by 5 meters per second. So it's now going at exactly 1 second. It's going 5 meters per second faster than it was at 0 seconds. So it increased, the velocity increased by 5 meters per second. So now the car is moving 5 meters per second. Now, after another second, from 1 second to 2 seconds, after 2 seconds, the velocity has increased by another 5 meters per second, so that now it's going 10 meters per second. So that means the car is speeding up. 0 seconds it was going 0, 1 second it was going 5, at 2 seconds it was going 10 meters per second. So it's speeding up. And how much is it speeding up? It's speeding up by a velocity of 5 meters per second for every second that goes by. That's what the numbers at the top above the arrows are telling you. Okay, so that's what acceleration means. The formula for average acceleration is A, it's lowercase a, equals final velocity minus starting or initial velocity divided by the total time, the change in time. So we use the abbreviations A equals VF minus V0 over T. And sometimes the change in velocity from initial to final velocity is called delta V. It should be a lowercase v in all those cases, but that's okay. So it's delta V over T. That's also a way of stating acceleration. So VF is final velocity, V0 is starting velocity, and T is change in time. Okay, so here's an example problem. When this roller coaster is at the top, it is going 0 meters per second. It comes to a stop. After 3 seconds, it has sped up, or speeded up, you can use either word, to 15 meters per second. So it's gone from 0 meters per second to 15 meters per second in 3 seconds. So what is its acceleration? So what is the average acceleration? So A equals question mark, that's what we're looking for. And then the numbers that we're given are a final velocity of 15 meters per second, an initial velocity of 0 meters per second, and a time of 3 seconds. So the formula we have for acceleration is acceleration equals final velocity minus initial velocity divided by time. So now we just plug in the numbers. A equals 15 meters per second minus 0 meters per second. You divide that by 3 seconds, and what you will get is A, acceleration equals 5 meters per second, or meters per second squared. Okay. Okay, you can change velocity by changing direction. This is the one that's not so obvious to most students. So this race car is going in a circle at 80 meters per second. Is its speed changing? No. It's 80 meters per second. All we care about is how fast, is the number. Is its velocity changing? The answer is yes. Its direction is changing. Therefore, its velocity is changing. Is it accelerating? Going in a circle at 80 meters per second. The answer is yes. Its velocity is changing. Acceleration is any change in velocity, either by speeding up or slowing down, or by changing direction. Okay, so we can see the relationship between acceleration, 5 meters per second, the time, and the instantaneous velocity. Okay, so you'll see down there, if we put all of these numbers back that we had in the earlier example, whoops, let me try that again. Okay, you see that the velocity at any moment in time is the acceleration, which is 5 meters per second, times the time at that moment. So at 0 seconds, it would be 5 meters per second times time of 0. That's the instantaneous velocity of 0 meters per second. At 1 second, the acceleration is 5 meters per second times 1 second, so that would be 5 meters per second. And at 2 seconds, the instantaneous velocity would be 5 meters per second times 2. That would give you 10 meters per second. So the instantaneous velocity, that is the velocity at an exact moment at time, is given by the acceleration times the time. So Laura begins from a position of rest. V0 equals 0 meters per second. So that's a term used in physics problems sometimes. Position of rest means you're standing still. Doesn't mean you're sleeping or anything. You're just not moving. If she accelerates at 4 meters per second, how fast will she be going after 3 seconds? So the instantaneous velocity is question mark. That's what we're looking for. We want the velocity at exactly 3 seconds, at exactly that moment in time, that instant in time. Acceleration equals 4 meters per second, time equals 3 seconds. So there's your formula. So VI equals acceleration times time, which equals 12 meters per second. So at 3 seconds, she's going exactly 12 meters per second. Just a little bit before 3 seconds, she'll be going a little slower than 12 meters per second. And just a little bit after 3 seconds, she'll be going a little bit faster than 12 meters per second because she's speeding up. She is accelerating. So this is red. Laura's instantaneous velocity at 3 seconds is 12 meters per second. If Laura is already moving at 2 meters per second when she accelerates at 4 meters per second, how fast will she be going after 3 seconds? So in other words, you have an initial velocity V0 that is not 0 meters per second. So you have to simply add that on to the previous problem. So now we must add the speed she is already moving to the final speed. This is the beginning velocity, V0. 2 meters per second is the beginning velocity. So that changes the formula to instantaneous velocity, VI, equals A times T plus the initial velocity. So VI equals question mark, A equals 4 meters per second, T equals 3 seconds, and VO, initial velocity, equals 2 meters per second. Now you just write that formula down, top center, and now you simply plug in the numbers. I actually wrote it as v0 plus at in this case, but anyway, it's the same thing. So it's at is 4 times 3 plus the initial velocity of 2 meters per second, and so she's going 14 meters per second. So in the previous problem, she was going 12 meters per second at 3 seconds. Now she's going 2 meters per second faster than that because she was already moving at 2 meters per second. Okay, distance can also be computed using acceleration, initial velocity, and time as follows. So distance equals 1/2 at squared plus v0t. So a car with an initial velocity of 10 meters per second accelerates at 4 meters per second for 5 seconds. What distance did it travel? So there's the formula. You simply plug in the numbers. 1/2 times 4 meters per second, the acceleration, times the time squared. So for 5 seconds, you square that number. Then you add the initial velocity, v0 is 10 meters per second, and it times the time, which is 5 seconds. Anyway, you end up with 100 meters. That's how far it traveled in 5 seconds. Alright, and that takes care of this lesson on acceleration. So the key is that acceleration is any change in velocity. Now, we only talked about a change in velocity by changing speed. We didn't talk about it by changing direction. That will come in a later lesson. Alright.